This is D2 dynamic programming. I'm looking at the minimum question here, and this is the second one in your workbooks. And we start by looking at this network down here and say that this one here is the very end state, the final state we want to get to. And so this one here is going to be at stage 1, and this one down here is also going to be at stage 1 because there is just one step needed to get to the end. The interesting one is this point C here. This one's actually at stage 2 because we could take 2 steps to get there, down there across. Yes, you can get there all in one go. We're putting it at stage 2 because you could take 2 goes to get there. G is here at stage 3, and so is that one there, which is a B down there, and A over here is at stage 4. Our dynamic programming idea is we start from the right hand side here and we look at each of these things in turn and say what we can do. So at stage 1 we could be at position F. Now what can we do from F? The only thing we can do is go to E. F to E is 8. And that's the only thing we can do. So there's no choices to make here. This is the current minimum. That's the best thing you can do. If you were at F, you'd go 8 to there. The other one to look at is D. Now, if you're at D, again, the only thing you can do here is go D to E. And D to E is 7, and so that is the best thing you can do at D. No choices to make at stage 1. There's just one thing to do each time. Let's draw a line underneath that to say we've finished that thing here, and let's go on to stage 2. At stage 2, we've got C here. And there are choices, C. We could go up there, C to F. We could go straight to the end. That's C to E. Or we could go down here. That's C to D. Let's see what sums we got here. If we go the C to F route, that's 5. There to there's 5. And then try to think, well, what was the best thing from F? The best thing from F we saw earlier was the 8. So that makes a total of 13 there. C to E is simply 9. And C to D is here, that's the 7. And we talked about D earlier. The best thing to do at D is the other 7. So 7 and 7's 14. Decision, which of these is the minimum? Oh, this one here. If you were ever at position C, if ever you get there again, then all you have to think about is the 9 there. Let's draw a line under that and go to stage 3. Let's talk about G first of all. And G, you've got 2 options. We could go straight across to F, and that's worth 8. And if you're at F, the best thing to do from F, we've had earlier, was another 8. That's 16. The other thing you can do with G is go straight down there. That was 2. That's so G to C, and that was 2. And the best thing to do at C is the 9. That's all you can do from G. So the best thing to do from G is those 11. Where else can be at stage 3? The other thing at stage 3 is down there, and that's at B. And your choices for B are B to C or B to D. B to C looks like it's 4, and we know the best thing from C is 9, so 4 add 9 is 13. B to D along the bottom there is 10, and we know the best thing to do from D was up here, an extra 7, 17. What's the minimum? The minimum's that one there. Stage 3 is all finished. On to stage 4, and the final stage here, we're now at A, and there are 3 things we can do. We can go up to G. If we went A to G, then that's 6. The best thing to do from G we had earlier was this 11, and so that would be 17. The other thing you could do would you could go down here, A to B. A to B is an extra 4, and the best thing to do from B, we've had already here is 13, 17 again. Or we could go straight down the middle here. That is A to C. And A to C is 10. You know what? That 4 there should have been an 8, didn't it? I've nearly finished, but made a mistake at the end there. That's annoying. So that A to B there, I saw that 4 there, but it was actually that 8 plus the best thing from B. The best thing from B was 13. So that made 21. A to C straight across the middle there. That's the 10. And the best thing from C was there. That's that 9, 19. The lowest of all of them is 17. So the best route is going to be 17. And it is. Starting at A and going to G. When you get to G, you end up going to C. Once you're at C, the best thing to do is go to E. And that would be the minimum distance across. Of course, you could do Dijkstra to find out the minimum distance, but the benefit of this is it could deal with negative edges, not just the positive ones that Dijkstra would get stressed with if it had negative values. That is dynamic programming a minimum.